Hi guys! In this world full of mystery, obscure and complex, notable scientists such as Albert Einstein, Werner Karl Heisenberg, Erwin Schrödinger, Max Planck, etc., they're the ones who contribute their knowledge and explain the behavior of matter and light on atomic and subatomic scale. But have you ever wondered what is light made of and what causes of electrons to be ejected on the surface of metal? By the way, my name is Kyoshi Takeuchi. If you are watching this video, then you are in the right place to learn, to discover, and to reveal the truth about the photoelectric effect herein I spec. When Einstein was bewildered, he immersed himself studying for a long time until he knew that the light was made of tiny packets of electromagnetic energy called photons, and this is where the photoelectric occurs. Photoelectric effect is the emission of electrons when electromagnetic radiation such as light with a sufficient energy strike a material which is metal. The material may be a solid, liquid, or gas, and the released particles may be ions, which is electrically charged atoms or molecules, as well as electrons. The faintest beam can able to emit electrons from the metal. However, if none of them have that minimum energy, none of them can able to emit or eject electrons from the metal. By the way, the electrons that are emitted or ejected from the metal are now referred as the photoelectrons. In order to eject electrons from metal, the frequency of the incident light must be greater than the threshold frequency of a metal. When we say threshold frequency, it is the minimum frequency of light needed to emit electrons from a certain metal surface, and the symbol that we use here is small letter f with the subscript 0. Whereas work function is the minimum energy that an electron in the metal needs to be emitted from the metal surface. To calculate work function is equal to Planck's constant times threshold frequency. If the energy of the photons is greater than the work function of a metal, hence the electrons will be emitted in a certain kinetic energy. Take note that an increase of frequency of the incident light will also increase the kinetic energy of the emitted electrons.